One simple way to tell how old a star is and if it still has a fluid interior, whether it be a gaseous type fluid or a liquid type fluid, is to determine whether or not it has a global magnetic field. And what you can also tell from it is if the global field is coherent, meaning it's not all over the place. Young stars, such as the Sun, have enormous magnetic fields pulsating through the entire star. This is from a NASA.gov website. It's magnetic field there, magnetic fields that are global, though not really as pronounced as some of the equatorial magnetic fields. Basically, the Sun is a young star in stellar metamorphosis and has many, many different magnetic fields all over. It doesn't possess one single magnetic field. It's a very, very young star, and all young stars look chaotic like this. As the star ages, actually let's wait till that one. As the star ages, the magnetic field shrinks significantly. This little dotted line right here is the size of the Sun to scale with the magnetospheres of these. So Jupiter its size isn't to scale as the Sun, but its magnetosphere is. So the magnetosphere of Jupiter is this much larger than the Sun, and you have, as Jupiter dies and cools, magnetosphere shrinks, it shrinks, it shrinks. But these are stars in intermediate stages of evolution when the global magnetosphere becomes more coherent. And these yellow lines are the solar wind. The white axis is the axis of rotation. The purple are Draftsman artifice. They're magnetic field lines. They don't actually exist. They just show you which directions magnetic fields are going. And the red is the axis, or the red is the orientation of that magnetic field. So basically what happens in stellar metamorphosis is the star has wild magnetic fields, and then they become coherent as the star shrinks, so it becomes one single global magnetic field as it cools and shrinks and combines elements into molecules. And then you have stars which are much more evolved. So you have Earth, which still has its global magnetic field protecting it from the solar wind. But then you have Venus, which does not have a magnetic field. Venus is a dead star. The solar wind is ripping away its outer atmosphere, and it's being torn to shreds. And over time, if that continues, the star will lose matter to interstellar space and get ripped apart. And here's Mars that's also getting ripped apart because it doesn't have a magnetic field to protect it. That magnetic field is essential to life. Thus, the establishment's version of events, meaning the star has to orbit in just the right distance from the star, is false. The truth is that the star needs a strong magnetic field to protect it from its host star. You could have a star, such as the Earth, a very old black dwarf, orbiting a star, such as the Sun, a very young one, really close. It's just the magnetic field needs to be strong enough to protect the surface from the solar wind. On a side note, if you have Mars, who doesn't have a magnetic field either, which is outside of the supposed Goldilocks zone, still cannot host life because it doesn't have a protective magnetic field. If it had a protective magnetic field, it would probably be considered inside of the Goldilocks zone, but unfortunately, this kind of information is falling on deaf ears. The establishment and NASA, they don't care about new theories. They want to regurgitate the old 1950s outdated version of science. And let's see, where is it at? Okay, I think that really covers it. Basically, young stars have chaotic magnetic fields like the Sun, and as they cool and die, they become global and they shrink significantly as the star dies. Eventually, it becomes like Earth, which has oceans. And then when the fluid interior stops moving and the star starts solidifying completely into a giant rock, basically, it doesn't possess the capacity to protect itself anymore, so the outer atmosphere gets ripped away. And eventually, it just becomes a dead world that cannot host life like Mars and Mercury. You can put Mercury in here too if you want. It's basically doing the same thing. So that's about it with the magnetic fields. I'll go over some more things in the future about water and where it probably is. In other words, water probably exists on stars that have strong magnetic fields much further closer to the host star and much further away from the host star because of internal heating, but we'll go over that more in depth in the future. Alright, have a good day.